Watch this. If the WAN link is 2 Mbps, which means we are having a wide area network where the bandwidth is 2 Mbps and round trip time between source and destination, which means from end to end. Round trip time means from here we have to go there and again come back. Round trip time is nothing but 2 into propagation delay. If round trip time is 300 milliseconds, what would be the optimal TCP window size needed to fully utilize the LAN? So which is nothing but by the time you send one byte and by the time you get back the acknowledgement, it time taken is round trip time. If you want to completely utilize this link during this entire time, how many ever bits that the link will allow, you should put all those bits. So how to solve it is, since the round trip time is 300 milliseconds and bandwidth is this much, these are the number of bytes, or these are the number of bits that we could transfer in 300 milliseconds. So in order to completely utilize it, all the 300 milliseconds we should keep the link busy, which means in 300 milliseconds how many bytes we could send or how many bits we could send? 2 into 10 power 6. See, it is saying that in 1 second we could send 2 megabits, and how much time we have? 300 milliseconds. Therefore in this 300 milliseconds the amount of data we could send is this much, right? So if you calculate it, I think it will come around 600,000. So it would be 6 lakh bits. So the 6 lakh bits we have to convert it into bytes because the options are in bytes and bits doesn't match. Therefore divide by 8. If you do this, you will get 75,000 bytes. Therefore this is the answer. So if you have to completely utilize the channel without wasting any time, then for the entire duration of round trip time you are supposed to keep on putting the bits. If you have to put those many bits, then your window should have at least these many bytes. Then how many packets? That depends on what is the size of each packet. Then you divide the window size by number of packets, the size of each packet, then you get number of packets. Anyway, they just asked in bits, what is the size in bytes? So the answer is this. Okay, look at the next one. Consider the default subnet mask for a network, which means they are saying that the default subnet mask for a network is 255.255.255.0, which is nothing but a kind of class C. I don't know whether it is class C or not, but then you could imagine that 24 bits are there in the network ID and 8 bits are there in the host ID part. Now, how many number of subsets and how many number of subnets and hosts per subnet are possible if m bits are borrowed from the host ID? Which means how many bits are there in the host ID part here? 8 bits. And from this 8 bits, if m bits are borrowed, from host ID, which means if you take out m bits, then how many bits are remaining in the host ID? 8 minus m. Therefore now 8 bits are given for subnet ID part and 8 minus m bits are given for host ID part. Therefore they are asking how many subnets are possible and how many hosts per subnet are possible. I told you that if you have m bits for subnet part, then the number of subnets possible is 2 power m. Previously it used to be 2 power m minus 2, but right now go for 2 power m. In case in the options, if you don't find 2 power m at all, then go for 2 power m minus 2. But then the right answer is 2 power m. If m bits are chosen for subnet ID, then the number of subnets is 2 power m. And if 8 minus m bits are present in the host ID part, then how many hosts are possible? The number of IP addresses possible will be 2 power 8 minus m, and from that you have to subtract 2. Therefore the number of hosts possible is 2 power 8 minus m minus 2. But then none of the options are matching. Actually I think they have typed it wrong. The option should be this with reverse, which means it should be 2 power m and it should be 2 power host ID minus m minus 2. Therefore it is not the answer, but the right answers are that. They must be having this typing mistake or something. Okay, anyway the answer is that.